So here we're learning about this idea called limiting reactants on pages 7 and 8. And make sure that you have a periodic table and a calculator nearby, because I am going to leave you a little bit of that last problem on page 8 to do on your own. But there are 4 examples between here and there, so I think by the time we get there, you'll really understand what I need you to do. So, what is a limiting reactant anyway? Well, the definition is the reactant that determines the amount of product formed in a chemical reaction, which means this is the substance that's used up first and makes less. We've talked about chemical reactions being like recipes, and we don't always mix things in quite the perfect amounts so that they make a perfect recipe. We might have more of one thing than another. And so, just like if you're making pancakes and you have 15 cups of flour, but you only have 3 eggs, the eggs are going to be running out before the flour. So the eggs would be our limiting reactant. The excess reactant is the one that is not completely used up. It's the one that has some left over when the reaction is done. So in that case, that would be our flour or baking mix there, because I had plenty of it to make all of the pancakes that I want and some left over. Now, if we used all the pancake mix, it would make more pancakes. But since the eggs run out first, those wouldn't really be real pancakes that we could make from it. That's just kind of imaginary, wishful thinking pancakes. So when we're solving these stoichiometry problems, we're going to end up getting 2 answers out of them, because we're given 2 different amounts of 2 different substances. So we're going to use those to work 2 problems, but the smaller answer is always going to be our real answer, because that bigger answer is not actually possible when we mix those 2 things together. This limiting reactant is the one that's going to determine how much stuff we can make, because it runs out first. It makes the smaller number of pancakes. So, how can I tell that something is a limiting reactant problem? Well, there's going to be 2 givens telling you the amounts of both reactants being mixed together, and the problem's going to ask you to find the amount of a product. So, here's an example. It says that a 16.2 gram piece of aluminum reacts with 61 grams of hydrochloric acid. So those are 2 numbers given to you, and it's talking about aluminum reacting with hydrochloric acid, those amounts of both of those things. And then someplace it says how many grams of gas are produced. So it's asking you, how much stuff do we make if I mix this stuff together? That's a limiting reactant problem. In contrast, a normal stoichiometry problem normally just has 1 number in it. It's 22.8 grams of NaOH. It's the only given. You can tell this is just going to be 1 stoichiometry problem for you to do. And all it is asking you how many grams of water are formed. Sometimes even it mentions that other substance. It says that much sodium hydroxide is reacted with hydrochloric acid. And sometimes it might even say reacted with excess hydrochloric acid. So this is telling you in the problem, don't worry about the amount of hydrochloric acid. There's going to be plenty of it. Evidently, the sodium hydroxide is the limiting reactant. It's going to run out first. So this isn't a limiting reactant problem because they haven't given you both of those amounts. They've kind of made that choice for you and only given you the number that is actually going to give you the answer. And then finally, percent yield problems can sometimes seem like limiting reactant problems because they will have 2 givens in them. But if you notice, this is telling you that 2.25 grams of sodium chloride reacts with some silver nitrate, and then this 3.45 grams of precipitate is formed. So it's telling you how much stuff was reacting and how much stuff you actually made. This is our actual yield, which we will need to find our percent yield. Also, percent yield questions have to ask you to find the percent yield in them, so they kind of label themselves. So there shouldn't be any huge confusion about them. There's never going to be any problems that are limiting reactant and percent yield problems at the same time. You're always going to have some very separate pieces given to you, very separate information. So these are the only 3 types of problems we're going to be working out this unit. So let's go ahead and look at the process for solving these problems. Now, this looks a little bit different than what's in your packet, but this I think is a little bit simpler and more straightforward. The packet has a little bit more information in it, but I know that sometimes too much information can get confusing and just wordy and you don't want to read that. So this is my simple steps. And I'll kind of show you how to edit your packet in just a moment to make it kind of get the information you need from here. You can also just write this off on a Post-it note or something separate and slap it on top of it. Or when you come to class next time, I can give you a copy of these steps so that you can just glue or tape that in over the top. But just make sure that you have the right processes down no matter which ones they are. So once you realize you have a limiting reactant problem because you have two givens to start off your reaction, you're going to set up and solve two stoichiometry problems. Start them with those two givens that you've got, and you're going to be ending at the same product, the same unit, same product. So there's going to be some similarity between some of these numbers you need to use. And then of those two answers you get from your two stoich problems, the smaller one is your real answer. That's the one that needs to have the unit and substance on it, and either circle it or box it so that I know that that is the answer that you think is correct. If you just give me two answers, you won't get credit for either of them being your final answer. I'm not supposed to be choosing between them, you are. And if you're asked to identify what the limiting reactant is, then the given that gave you that smaller answer is your limiting reactant. So just follow that final answer back to the given, and that is what your limiting reactant was. Now, some problems don't ask you to find how much excess reactant is left over, but if they do, it's really just going to start from the limiting reactant again. So it's really important that you do those first two steps. As you notice here, this is a 4-step process in total to finding that excess reactant, but it is always going to start with you finding the limiting reactant first. And once we know what the limiting reactant is, what we're doing here in these 3rd and 4th steps is just figuring out how much excess reactant got used up while the limiting reactant was getting used up. So that after we figure out how much of it got used, and we knew how much we started with, we can subtract the two. Figure out how much we were given minus used tells us how much is left over. Now, this is going to mean one more stoichiometry problem if you're asked to find how much excess reactant is left over. But that stoich problem is just going to start with the limiting reactant as your given. So you're starting from one of your givens that you already started a problem with earlier. But this time you're going to end at the amount of your excess reactant, and you should aim to probably have the same units that you were given so that you can do this subtraction later. And that's all you got to do. Go from one reactant to the other, find that answer that tells you how much got used, then take given minus used, and that tells you how much is left over. So let's get those steps on the page to match what I just said, if you're not planning on getting that paper from me or just writing out those other steps someplace else. This looks like 3 steps, but this first step really is kind of just get ready to do stoichiometry. You need a balanced chemical equation, and you need to have those 2 givens for those 2 reactants to be able to do the 2 problems that we're about to. But step 2 is really where you start doing stuff and solving the problem. So you're going to be setting up and solving 2-dimensional analysis problems. I would recommend that you add this little note reminding you of how to set those up. You're starting with your 2 givens, but you're going to the same product, whichever product it's asking you for. And then once you solve your 2 problems, the smaller amount of product is your real answer. And the smaller amount of product came from that limiting reactant so that you can find that. But you need to make sure that you identify your real answer. So that's our limiting reactant problems. If we are asked for excess reactant, then of course we're going to have to work from limiting reactant to excess reactant, like I said. This just kind of sets the stage after you've done this other stuff, but of course we'd have to do that first. That tells you how much excess reactant was used, and then we are going to be subtracting like it says in step 3, but it actually has that backwards, so I'd like you to cross that out, and then just write given minus used equals leftover. So we always have the given amount of that excess reactant. It's in the problem. You just need to calculate that amount used using one more stoic problem, and then you can do the subtraction to find the leftover or the remaining excess reactant. So that should be good enough, but if you want those steps that I gave you, I do think it's a little bit simpler, but to each their own. You choose. Let me know what I can do to help you. So let's look at an example here. Here it tells us that 6 moles of barium chloride are placed in 5 moles of H2SO4. So that's the reaction we see down here, which luckily is pretty simple to balance, just a 2 there at the end. Wants us to figure out how many moles of precipitate will be formed, and I'll tell you a little bit later how to predict what the precipitate is going to be, but for right now, just imagine that asks you for how many moles of barium sulfate will be formed, and of course how much excess reactant remains after completion. So we're just going to start from that first given that I see, moles of barium chloride, and this is going to be a 1-to-1 ratio to convert from barium chloride to barium sulfate, and that tells me that if all the barium chloride is used, then that will make 6 moles of barium sulfate, but I have another given to use, so I have another problem to set up, still a 1-to-1 ratio. So from those 5 moles of sulfuric acid, I could make 5 moles of barium sulfate. I have 2 answers. Which one is my real one? My real final answer is always the smaller one. So 5 moles of barium sulfate would be formed from that reaction. That's our answer. And if we follow that back, H2SO4 is the reactant that gave us that answer. So that is our limiting reactant. That's also going to be our starting point in figuring out how much excess reactant is remaining. We take those 5 moles of H2SO4, use that 1-to-1 ratio to find how much barium chloride got used when we reacted 5 moles of H2SO4. Unsurprisingly, that's 5 moles. And since we started with 6, 6 minus 5 means there's 1 mole remaining. Not too complicated, and you might have been able to predict that if I had less H2SO4, it was going to be the limiting reactant. But that's mostly because this was a simple mole-to-mole problem with a really simple balanced equation. These next few are going to step it up little by little, but the process is still the same. Here, we're mixing equal amounts of aluminum and oxygen, and this is a synthesis reaction here, 4-3-2 when it's balanced. If we start with those 3 moles of aluminum, that would be making 1.5 moles of our aluminum oxide, and with 3 moles of oxygen, because that's a 3-to-2 ratio, we could make 2 moles of aluminum oxide. So even though I put in equal amounts, because my balanced chemical equation needs more aluminum for each time this reaction happens, the aluminum ran out first. So our smaller answer is still our final answer, making sure we got our number unit substance all together in that final answer. This also means that aluminum is our limiting reactant, like it was asking us to identify. And if I use those 3 moles of aluminum, I can calculate how much oxygen got used up when reacting with that aluminum. It's technically 2.25, but I rounded that to 2 sig figs here, so 2.3 moles of oxygen got used. When I subtract 3 minus 2.3, that means 0.7 moles were remaining.